if there is any metallurgical change? We always believe it.
The state of beta palladium hydride is extremely hard, a very hard substance compared to the soft raw palladium. But in these cases, when we finish with a rod like a 4 millimeter rod, the additional intercalation of lithium into the lattice makes it extremely hard, and it will totally destroy a brand new hacksaw blade if you try to cut it. We had to use about 2 blades and take about 15 minutes to cut a 4 millimeter rod. So it's an extremely hard substance, and so there definitely is surface metallurgical changes, at least with lithium present.
Why should turning off the current from the cell quickly lead to very large reduction of energy?
It leads to large and steeper concentration gradients. Agreed, it's moving in the other direction, but there is a sudden concentration gradient developed in the lattice whenever you change the...
Why does it lead to a sudden concentration gradient?
Because that will lead to higher compression. Because why does it...
Yeah, have you done a calculation that says...
Well, you have a steady state concentration gradient.
Yeah.
And when you change it back...
Turn it off quickly.
When you change one of the boundary conditions sharply, then there will be a sharpening of the concentration gradient.
Well, if you think that this is an important effect, which you obviously do, why don't you try to control for that? That is, get larger effects, but not catastrophic.
We have done some potential step experiments, but again, these things must occur over long times. And in one experiment, we saw increased rates of neutron production on a 1 millimeter rod when we pulsed the current quite drastically over some periods of time.
To your knowledge, has anybody seen these large excess heats 10 to the 9 times larger than conventional nuclear reactions at least two?
With regard to the excess heat, given the long duration of the experiments, have you integrated the total electrical energy input and compared that to the total thermal energy output for the entire duration of the experiment? Is that really...
Yes, the one we reported in the paper, we reported 4 megajoules total integrated energy. And more recently, we've obtained 50 megajoules on the 4 millimeter rod for 800 hours.
The question had to do with the ratio of the electrical...
That's the excess energy. That's the excess energy.
Are your measurements consistent of neutrons and tritium production consistent with equal branching ratio?
The amounts of helium, the amounts of tritium and the neutrons measured were approximately the same.
Do you think you've accounted for all the tritium? Is there some tritium trapped still in the palladium? Not measuring?
Well, we're making steady state measurements outside, so we assume the neutrons would come out. But the steady state tritium in the literature is, in the electrolyte is what we measure from the equations. We know what that concentration is, we know what the separation factor is, and we know what concentration that must lead to over what period of time. So from that we can reduce the absolute amount that has been generated. It's pretty consistent.
When you say that the excess energy is 4 megajoules, what's the total energy?
That's the total energy would be that plus.
What is the comparable number?
Oh, I'd have to calculate it. You would.
20 megajoules? We're talking about small differences between large numbers, or
it would be the voltage times the current. The voltage minus the 1.54 times the current. All of that multiplied by the total time of the experiment.
But is that number comparable or very much larger than
that number would be in the typical experiment would be larger, about probably a factor of 2 in the typical experiment.
So the excess energy is approximately twice the total energy.
Well, they were present in the percentages in that table. They're of the total energy. Yeah, the total energy would be the one with the twin stars in that table too.
It was in your second table.
In the second table. So they're on the order of 10 to 50, 60%, something like that.
The table in the paper was calculated and had 3 different reactions, and one was an excess over joule heating.
Right.
And I believe only 1 out of the 9 entries had a number greater than 100%.
That was the 4-millimeter rod, the last 4-millimeter rod, and 111%.
So doesn't that
That's
say
correct.
that the difference is over the joule heating alone or small? Or? I mean, I may have misunderstood, but I thought there was only 1 entry in that table which had an excess above 100% of the joule heating.
That's correct. It was the 111% 4-millimeter rod. That has now been exceeded quite a lot by this other 4-millimeter rod running at a half an amp per square centimeter. But in that table, that's correct.
I hope that you'll join me in thanking Dr. Pons